My friends, welcome to this week's weekend special. A while back, I started practicing on the model Mania. So these are SolidWorks property and they have a challenge models for each year. There is a competition. So I'm not going to the competition, but I'm practicing on those. And I have done some of these and some of them, the fillet issue is so severe in the FreeCAD that I couldn't perform. So today I'm going to work on Model Mania 2008. The link is right here if you want to follow along. But here is a fair note. I won't be working on these fillets. This is my not definitely my first time working on this model, and then every time I start working on these fillets in FreeCAD, it becomes an issue. So I will be building this model, both phase 1 and phase 2, and do the FEM analysis, however, without the fillets. So we won't be worried about the fillets anymore. And although the competition says the phase 1 you build it and then you get to see the phase 2, I'm kind of like cheating. I'm looking at both of these at the same time and then building the model to for an easy transition between phase 1 and phase 2. So without further ado, let's go ahead and start working on this. On phase 1, I will be starting on like the whole sketch. I'll be building this whole sketch first, which is a tricky one. But so I'll be building the whole sketch first as a master sketch and use that to actually build this model in 3 separate parts. So although I will be building the whole sketch all together, I won't be extruding that at the same time. I'll be separating that in 3 different parts. I'm gonna keep on this plan on XY plane and start sketching. So let's go ahead and relocate the image to the center. Now if this is your first video on my channel watching on this one, I have a long-standing series on this one, FreeCAD modeling for beginners. I invite you to visit those videos, watch those videos, but I'll try to make it good enough if you are the first time watching this video. All right, so what I did was image processing. I don't want to describe that right now because this image processing thing is gonna get away in the next FreeCAD version 0.22, but there are like multiple videos on my channel how I do that image processing. So I want to start sketching on XY plane. And as I said, I'll be building the whole thing as a master sketch. So let's go ahead, start working on that. I want to start with a straight line between this point and that point. And then I want to draw this reference line. I think I misplaced this. So these two will be the same. And then these two will be the same. And obviously this will be a construction geometry. This is a reference line only. I want to go ahead and apply that constraints. I normally do the sketching first and then apply the constraints. But today, for this model, it is important that I apply these constraints as soon as possible because that will actually place things at the right where they should be. All right, and then I also want to draw this construction geometry between this point at the center of this carved slot. That way I can go ahead and apply this 30-degree angle right there. All right, I'm not worried about this moving thing right now. We'll address that in a moment, but let's get back to drawing different parts. So on this one, I can actually go ahead and draw the whole circle, but I won't, which I will explain towards the middle of the video. Right, I want to take this point on line constraint away, so that way this is free moving, and then I want to go ahead and apply a tangential constraint on this one, which is important, although it will be on the same axis, but it is important that I took it out. All right, let's go ahead and focus on this curved slot. The first one, it will be on this point, on this line, from that line to this line, and second curve will be right there. If it was a straight slot, we could use a slot from the primitives in the part workbench, but it's a curved slot, so we have to build it ourselves. So this is radius 12, and that actually applies the same constraints here as well, but we can try making them equal. And then this is radius, I guess we don't have to do that, it's already there, and this is there too. The one thing we'll have to do is apply some tangency at all of these 4 joints. So there, we have 3 degrees of freedom. We'll worry about those freedom later on. Now I'll draw another straight line between this point to that point. Now here I want to, okay, let me keep this line right there. So there is this curve, which is essentially a fillet. And I want to avoid that right now because that creates a problem in FreeCAD later in the process. So let's go ahead, forget about that curve, and bring this line all the way to here and place it on this curve, so it would be a point on line constraint. And then I want to draw this endpoint and rim point curve and bring it up here and say right there. So before I apply the radius, I'm going to go ahead and apply the tangency here at both ends, and then I say this radius is 175. It is still switched a little bit. I guess we will have to fix a few more positions on this one. So let's go ahead and start working on the inner curved slot. On this one, the constraint will be pretty simple. This is radius 6, and that's all we should have applied other than the tangency. All right. One thing I can say, I can actually constrain this one 17.5, see if that actually helps us stabilize the model just a little bit. Okay, there. So it's kind of like we are at the point where the model is a little stable, and we have 3 more lines to draw, one of them which is this inside half circle, and then we switch back to endpoint rim points and draw a line. Again, this corner supposed to be a fillet, and we are avoiding that one, right? And there, we don't want to make any tangency right there, so these 2 points are just point on line constraint. I want to trace these 2 centers at the same point, and then see there is a 6 mm gap between these 2 points. So if it is 175, I take this radius as 175 plus 6, right? So that kind of makes it parallel because both of them are coming from the same center. On this one, the 6 is a different deal, and here we can make it easy. So between these 2 points, the distance is 6. That's easy to apply because both of these lines are horizontal, and it's easy to apply that. On this one though, it's not horizontal or vertical. So what I want to do is I want to take a construction geometry and draw a line between these 2 centers, both centers, for the respective arcs. Now we know that this line is perpendicular to both arcs. Now I can go ahead and place 2 points on this line, and this point will be on this arc, this point will be on this arc, right? And the distance between these two would be 6. So that kind of solves that issue, this inclined length issue. And we have 1 degree of freedom, which is here, and I think I know where it is. So this is, there should be a tangency between this point, this line, and this line, and that kind of solves our issue. So on this part we did only half of it, so let's go ahead and complete the circle. Here I want to say, I want to make note of this vertical line. So this is not a like a full circle. This will come all the way here, and then the joining will be a vertical line of 6 mm. So this length is 6 mm, and then the inner circle will follow the same trend. We come all the way up here, and then so I divided this line into 2 to make it equal. That way, that's me saying these are symmetric, and then one of them is 3 mm. And then we come back to this where it says diameter 11, so that's radius, diameter 22, radius 11. And then it says the distance between this line and this point, or like this farthest corner on the circle, is 2450. So we go back to the point style and place this point on the axis. We know that that's the farthest point, and the distance between these two is 2450. So that's our master sketch. Everything's like perfect except these corners. We'll try to build up those corners later on, but let's not worry about this right now. And I'm gonna go ahead and rename that as sketch master. And I want to use this sketch to build this model in 3 parts. So this is, I'm going to say, left part, that's the right part, and there's the middle part. So I'm keeping this sketch there and then copying it, Control C on the keyboard, and then pasting it, Control V 3 times. So this is, let's go ahead and say left, and then we name this as middle, and this as sketch right. So we will work on them one by one. I'm going to hide this master sketch. Now these are copy paste, so we can change them independently. These are not clone. So I'm going to go ahead and hide these two and keep this one. So this one, I want to keep only this left part. So I'm going to go ahead and select everything else and make those construction geometry. So this construction became solid there. So that's one way of saying this left of the right side is irrelevant for this sketch. They are there if I want to. I want to make them active, but now we only will get this left part. So let's do that same thing for the middle one. When I was building this, I did not go the solid, so there are like two different parts. This is the reason that I did it. I'm going to take all of these and make them construction geometry, and leave this middle part, and then take all of these, make them construction geometry. So doing so, we have an not closed sketch which won't work, so we'll have to do a little bit of work on this one. So we want to close these two lines here. So I am going to take another arc between this point and that point, and I'm going to say these 2 points are coincident, and I can make these two coincident. Theoretically that should work, but it creates some problems. So that's kind of like over constraint, and that's like too many complications. So let's go back. What I want to do is I want to take this point and place it on this line, and that just does the trick. As long as it's constrained, I'm okay with that. So let's do the same thing on this side. I want to make these 2 points coincident, and then take this point and make it on this line, and there we have a closed sketch, which is important. And then right side should be easy. Take everything on the left and make it construction geometry. Well, this one will have to bring it back as construction geometry, and that's it. That's the right side. Okay, so we have the master sketch. We don't need that anymore. We will use that to duplicate this 3, and now we will extrude that one by one. So let's take a look at this figure. So the left side, it will be a 30 millimeter. Right side will be 16 millimeter. The middle one will be 14 millimeter, but they are not lying at the same length. So we'll have to find a common ground and then make him work. So what I did, I found a common line and then divided all 3 parts on top and bottom of that common line. So let's go ahead and work on that. So on the left side, if we imagine a center line here, the lower part is 20, upper part is 10. I want to take the left one and extrude that for 10 upward and 20 downward. And the middle one, we want to do the same thing, but from the center line, it will go up 7 and come down 7. On the right side, it will be 8 and 8. Okay, let's take a look at what we did. What we did is we build this object based on how they're laid. So the distance between this line and this line is 1. Let's take a measuring. So the distance between these two is 1 and these two is 1, which satisfies our requirement. Let's see how it looks. So the distance is 3 here, and this is 13 here, and this whole thing is 14. So that is 30 millimeter in total. And we have another thing. So the distance between these two should be 2 millimeter. So there, the distance is 2 millimeter top and bottom. I think that satisfies our need, and that is our phase 1. So this is our phase 1 completed. Phase 1 says we'll have to build this model, and we did it without the fillets. As I mentioned, let's make these. So I'm going to rename that way I can come back to the model when I work on the phase 2. And I want to make them fusion. So this is, I'm going to say phase 1. All right. Now I can try to make that fillet here. I'm sure it will work because it's only 2 of these, but I cannot make all of them. So there. So we built it as specified in the technical drawing. There is a corner fillet. The blue are R2. We did it. The rest of them, I don't think it will do it. So this is only 3. This technical drawing asks for 4 millimeter fillet, which I'm sure it won't work. It probably will take 1 millimeter. Nope, it won't even take 1 millimeter. So we know that FreeCAD has this issue. Hopefully it will be solved soon. So until then, let's not worry about the fillet. We know that they are there, just not worry about it right now. So that's the end of phase 1. I want to go start work on phase 2. So this is phase 2. The distance between phase 1 and phase 2, the difference is this thickness. It used to be in phase 1, this thickness is 6 on the middle part, on both arms. On the phase 2, it is 14. So that's one change. And then this thickness is 8 on the mid part, which is 14 on the phase 1. So this, the thicker part becomes thinner, the slim part becomes wider. So that's the phase 2. And then it will apply, it will call for FEM analysis. We will try to do that, but let's work on this phase 2. On the phase 2, I'm going to delete this fillet. I know that it will create an issue. So we deleted that fillet and start working as phase 2. All right, so we saved it. Now this phase 1 will be actually phase 2. And in the phase 2, first thing first, we will have to go to the middle part and update this sketch. So this 6 millimeter will be 14. So watch what it does when I say this is 14. 14 there. So it thickens the part, but look at what happens here. This slot comes over and kind of like gets into the bar, which should not happen like that. So we'll have to fix that, and that's why this fillet here would always create an issue in FreeCAD. I'm sure it will be solved in like 2 years or so. Until then, I want to bring this point on this line. So bring this point on this line, right? And take this point on this line, on this curve. And the gap is actually a curve with center from the left side. So we want to take it from here to there and try to make these two Coincident? It worked. And we'll have to do the same thing on here. So this is 181, which is like 6 thickness. Now it will be 14. And that does the same thing. It is more visible on this side. So let's do the same thing. Delete this constraint. Take this point back. Take this point on this line, right? And then fix this part. So if this was not an issue, we would be able to do this in the configuration table. Because this part is not working fine, I'm sure there are some way that I probably don't know, some advanced way in FreeCAD, but until now that's the limit of my knowledge, and it's working fine with me to do this manual thing, and that's one reason why I'm not doing this in a configuration table. All right, so we have that second part worked up. So this is now thicker. Now we'll have to make it thinner on the Z direction wise. So this middle part we have 7 and 7. Now it will be 4 and 4. Let's see, 4 and 4. So everything else at the same location. The only thing is this middle part became thin on the Z direction and thicker on the Y direction. So that is our phase 2 solved. That's what the phase 2 calls for. 14 and 8. We got that. Pretty simple. Now, just to make this simple, we had to make these 3 parts independent, so I could come and then change this sketch without much of a referencing between all of these. Hope that explains. All right, I think that's the half of phase 2 completed. Now we go to FEM. It says on this phase apply total 400 newtons and then fix this phase. So let's see if we can do that. Let's go to FEM. FEM comes with the FreeCAD, so if you don't have it, it's there. You don't have to install it. And on FEM, we'll just go step by step. Like that's how the standard procedure is. We'll go with analysis container and then add a solver, add a material. What it does is it says use FEM to analyze the 2 configurations and determine which is stronger. So we'll have to do FEM analysis on both parts, and we will try to get the result out of it as much as I can from the FreeCAD. I know that it won't give us any factor of safety, not readily. We'll have to calculate it. So, but we can find this end goal, like determine which is stronger. We definitely can do that based on stress and displacement analysis. All right, so for this one, we applied aluminum generic. As long as we apply the same material for the phase 1, we should be fine. All right, now come to the fixed part. We add this point and hit OK. So that's our fixed support. And then we add load on this face. So this is the load button, constraint force, and then we add on this one. It says upward. Actually, our direction says downwards and say reverse direction. So that brings this downward. And it says 400 Newton. So 400 Newton. Cool. The last thing on this phase, on the analysis one, is to take this object and create a mesh. And I found that without going into much details within the meshing thing, the finer the mesh is, more computing power it takes, but there is a good chance that this will work out. So I'm going with the 10 millimeter mesh, see if it works. Okay, now we have in the analysis container, we have solver, material, the support system, the load system, and the mesh. At this point, we double click on the solver, write the INP file, and then run calculix. We are looking for this nothing red in this here. As long as there is nothing red, it worked. All right, so it worked for us pretty good. Now what I want to do, I want to hide this mesh right now and come to CCX results and double click on it, and I will be looking at displacement and stress. So on the displacement, we see that maximum displacement is 1.16, and that's the value we want to make note of. And I also want to make note of the stress, where it says the maximum stress is 133 MPa. So those are the values we need. We can get out of it, but before getting out, I can see actually how this model will act under load. So here I come to show, I check on this box and then see. So that's how almost it is like 100 times exaggerated. So let's take it down to 10. So it is showing you 10 times more of what will happen. It will have 1.16 millimeter displacement at the furthest corner because it's a cantilever system, and that's how it will bend. So the red part means that's the maximum deflection. On the stress side, the maximum deflection point has the minimum stress, and that's like a rule of thumb. So here we can see, let me go ahead and hide this. There. Now we can take a clear look on the stress part. So it explains that near the support, it will have the maximum stress. So the red part is right here. It is stressing, the tension is right there, and the compression is at the underneath. And that's how it's stressing. All right, enough fun about phase 2. Let's go open up phase 1. So we have phase 1 opened up. We want to do the same thing. So analysis, solver, material, aluminum generic, and then we want to say the fixed part would be this phase, and then the load part would be this phase. We want to do the reverse direction, and then we come to do the mesh, which we will do an end mesh with maximum size 10, and apply and OK. And now we come to write the INP file and run calculix. Pretty quick. Simple object takes less time. So we have, I'm going to go ahead and hide these two and go to the CCX results. And now first thing we want to take a look at the displacement. And on this one, we take a look at the maximum displacement is 1.18 micrometer. We want to take a look at the stress, the maximum stress. We have that as 176 kPa. The pattern is same. So on this one, actually, because the displacement is so small, right? This 10 times displacement is still small, but we can see the very little displacement at the end right here. But the pattern is the important thing, and then it shows up same. So now we have two values. We could go ahead and then calculate the vector of safety. So these values tells me that phase 1 is definitely a better design than phase 2. And actually we should, we don't need to look at the FEM analysis. We could tell that by looking at the model, because this is the bending profile and this is the thicker the beam is on the depth wise in the direction of the load, the better design. So in phase 1, the direction of load and then the thickness of the beam is thicker compared to phase 2. So obviously phase 1 is a better design. The factor of safety, though, we can calculate it. (983). So, and 133 divided by 0.176. So that's 755. So it comes around the same area, definitely better than 1. So we can say our mathematics kind of verifies our basic beam design. In this case, like, strength of material, the direction of the load, the thickness of the beam should be higher for a better design. Anyway, I hope you like this video. It's already a long one. So if you have any question, comment, or any trick to make these fillets work, please leave them in the comment section below. Thank you for watching. If you have any question, let them know as well. I'll see you in the next one.